talking about how to use significant figures and how to appropriately problem solve. Significant figures. Calculations may contain two types of numbers, exact numbers and measured numbers. Exact numbers are part of a definition, such as the 2 in D equals 2R. Measured numbers are just that. For example, we might measure the radius of a circle to be 10.3 centimeters, but that measurement is not exact. When dealing with measured numbers, it is useful to consider the number of significant figures. The significant figures in any measurement are digits that are known with certainty plus one digit that is uncertain. It is easy to create answers that have many digits that are not significant using a calculator. For example, 1/3 on a calculator shows as 0.33333, etc. But if we've just cut a pie in 3 pieces, how well do we really know that each one is 1/3 of a whole? Significant digits. Well, the first thing we have to do then is we have to be able to determine how many significant digits are there in a number. So in our first example, it says estimate the mass of a rock to be 45 pounds. It's understood the first number 4 is correct. We know it's 40 something pounds. The second digit is an estimate. Right, so we're estimating it to be 45 pounds. 40 plus about another 5 pounds. So we would say this number has 2 significant digits. Anything that we know that is correct and estimated is a significant digit. So down here it says how many significant digits. In our first one we have 393. Well, the 390 we know to be correct. It's 390 and some. So this 3 is an estimate. So we would say there are 3 significant figures. 41.09. These first 3 are measured numbers. This last one is an estimate. So we're saying it's almost 41.1. So we would say there's 4 sig figs there. In this case right here, the 0 was measured, the 8 was measured. The 9, on the other hand, is an estimate. So there's 3 sig figs. 109.3, there's 4 significant figures. Sig figs continued. Well, here's some more examples. 1.005, 4 sig figs. 0.23, 2 sig figs. I made a mistake on our last one here. My apologies. In this 0.89, there's not 3 sig figs. I got a little bit of a hurry and haven't been awake long enough here. There's only 2 sig figs. This 0 right here is a placeholder. All right, we don't include placeholders because we could write that as simply 0.89. In this case, 0.023, 2 sig figs. 6.000 is 4 sig figs. The reason this is 4 significant figures, because some students say, well, why aren't these all placeholders, Mr. Kimmel? These right here are significant because if they weren't significant, we would not include them. We would just simply write the number 6, and then we'd have 1 sig fig. But if we write 6.0, that means 2 significant figures. We've measured the 6 and we've estimated the second one to be 0. It's not any bit closer to 7. So we do not include or do not count unless the number in front of the zeros. Some of these are just placeholders. So like here, if there's no number in front of these zeros, we don't include them as significant. Significant figures in calculations. When multiplying and dividing quantities, leave as many significant figures in the answer as there are the quantity with the least number of significant figures. So let's talk about that multiplication then. So, alright, an answer cannot have more significant figures than any of the numbers being used to find the product or quotient. Round to the last sig fig. So in this example, when we multiply, 3.55 has 3 sig figs. 12 has 2. So my final answer can have at most two significant figures. So the way we do this is we go ahead and multiply this the way you normally would. And we don't worry about sig figs until we have our answer. So I'm going to go ahead and multiply it, 3.55 times 12, but it's negative, so we're going to get negative 42.6. But I can only have two sig figs. So the 6 I got to get rid of, but what does the 6 tell the 2 to become? Negative 43. And that would be my final answer right there. The next one, negative 24.08. There are 4 sig figs in this top one. 4, notice it's just 4, it's not 4.0 or anything like that. There is just one sig fig here, so in my final answer I can only have one sig fig. 24.08 divided by 4 will give me negative 6.02. I can only have one sig fig, so the 0 tells the 6 to stay a 6. And we get negative 6 then is our final answer for that one. When adding or subtracting quantities, leave the same number of decimal places rounded in the answer as there are quantity with the least number of decimal places. Alright, so what does that mean? In our example here, alright, keep place values that all numbers being added have. So the 2.3 doesn't have anything in the tenths or the 100 spot. So when I'm done adding it up, I'm not going to keep anything to the right of that dotted line because 2.3 doesn't have anything in that 100s or the 1000 spot. But I'm still going to add it first. 6, 8, 7, 9, and then we have what, 6, 8. I may have did some mismatch adding here. I think we're good here. 6, 9. Yep, everything looks good to me. But I'm not going to keep the 8 and the 6. But what does the 8 tell the 9 to become? It tells us to round the 9 up. So this right here is going to become 19.0 because again the 8 told the 9 to be rounded up to a 10. Carry your 1 gives me 19. Alright, we'll talk a little bit about problem solving. Things that we should do. Read the problem carefully and analyze it. Where appropriate, draw a diagram. Alright, we're going to talk about this a lot in physics. Draw a picture. Number 3, write down the given data and what is to be found. Make unit conversions if necessary. So that's what commonly we're going to refer to that as a list. Determine which principles are applicable. Perform the calculations with given data, and then consider your results. Consider the results whether the results are reasonable. All right. Table at left describes several types of examples that are used in the text. Primary mathematical in nature. Think it through solution. Integrate example. Conceptual, multiple choice, mathematical follow-up. Sections, conceptual reasoning, quantitative reasoning, and solution. Conceptual example. In general, needs only reasoning to obtain the answer, although some simple math may be required at times to justify the reasoning. Reason and answer. So, we'll talk more about these problem-solving techniques as the trimester continues. So, what did you learn today? All right, I want you to take time and answer this on your in your notes. How do you determine the number of significant figures in a number? All right, and how many steps are there in problem solving? Hey, I'll catch you guys on the flip side.